My name is Bertil. I work at Verdo as a engineer in the planning department and business development. I will tell you a little bit about our company, Verdo utility company, and I'll tell you about district heating and district cooling in Randers, which is the city I work within, and the status and the future scenarios we are looking at and why we're doing it, and development phases we do for district heating and some possible system setups, and how we are right now looking at district cooling development. This is a picture of our city, future city. Well, I'll come back to that. It's located in mid-Jutland around a big river called Gudenåen, which is, I think, maybe the biggest river in Denmark, but it's not big in a European perspective. This is the two main cities that our company covers, and I'm situated in Randers, which is a city with a size of 65,000 inhabitants, and we have around 38,000 district heating consumers, and we supply water to 26,000, and we have a CHP plant which also produces electricity simultaneous to our heat production. In Herning, we also have a district heating network supplying 38,000 consumers. In Randers, we have a pier here at the center of the city, which is where our CHP plant is located today. It's a biomass fired plant of around 200 megawatts, and it is planned to be shut down at 2036. So right now we are working on scenarios for what should we do instead. This is the municipality's dream of the new harbor. And we might have the option to leave the chimney, but not much more room for other production facilities for producing heat. So what should we build? And we're looking at all kinds of new technologies. These ones are the chosen ones we look at right now. Here's heat sources are mainly air or fjord, the river, which means river, electric boilers, storage systems, and excess heat from industry, wastewater. It is district cooling, and maybe wind turbines for producing electricity for all these heat pumps. So that's our main focus right now. What should we start to plan to build right now in 2036, and what can we already start right now? And what we could start right now is district cooling and excess heat. And we are troubled by this electricity system today with the very big fluctuations annually and also on a daily basis. So of course, avoiding the high peak price hours is very beneficial, and also using these almost negative prices at times. So we are looking into storage systems, of course. And we are looking at different kind of base load and peak loads. Heat pumps are quite expensive. They have a good COP. And we also look at electric boilers with, of course, less efficiency, but much lower prices. So the combination of these things. And for the base load, we also look for that, as I mentioned, industrial excess heat from industry and district cooling built with heat pumps. And also the synergy between district cooling and bringing home excess heat. A lot of the industrial heat is maybe only 30 to 40, 50 degrees, so that needs heat pumps. And if we build heat pumps for district cooling, we could easily incorporate it in our system. The district heating grid looks like this in Randers city, where we have the central placed power plant here, CHP plant. And yeah, I mentioned the numbers early on, but what we also are doing right now is looking at the potential for district cooling. And we have located around 7 areas that we find interesting in cooling, which is the city center, which is hotels, shops, businesses. And the further out you get, the more industrial it gets. And there are different types of cooling loads in these areas. The business and hotels are more, and offices are more in conjunction with the outdoor temperature, whereas the industry is more or less flat cooling demand year round. So we look at different kinds of cooling customers, and we have a potential of around 65 megawatts of cooling, but realistically, maybe only 25 to 30. It depends on how good we can access these customers and build cooling centrals and cooling plants for them. A lot of this heat is, of course, in the summertime, but a lot of it is also year round. But building these heat pumps will be so beneficial if they can get some additional heat sources, for example, the river or outdoor air. It will be a good contribution to the heat system. And we are evaluating different sites for production placement around the city for the larger production sites. But of course, cooling can be placed around the city. And this is where the CO2 gets interesting. And yeah, we place the production site according to a lot of different considerations. Of course, the placement of the heat sources and the power infrastructure. It's a very important. Tariffs and fees for using electricity has a huge impact on the business cases on different production sites, and also the district heating grid. Where can we actually supply heat to the grid, or do we need to totally turn the grid around or upsize or renovate? And then, of course, also area conditions. Is it available in general? Is it any protected nature areas, or etc.? But all this led to some scenarios that we could look into. This one is just one scenario in one location where we will have a base load of heat pumps with district cooling and excess heat, and then heat pumps with based on river maybe, and heat pumps based on air, and then electric boilers for the peak load. This is just a distribution of production in 1 year. You see the base load we can easily cover with almost cover with excess heat and district cooling and a little bit of heat pump. What you see is that the black dotted line is the actual heat demand in the city, and this is the yellow ones is how we're gonna charge our accumulators, our heat tanks. So there will be periods with almost no production and only taking heat from storage. And this is an example of an industrial area where we are planning some DC district cooling development. And one of the issues around such sites is that there might be very good cooling needs around and good heat sources for a heat pump, but they are not so close placed. And here we have, in this area, we have a reserve capacity central. So this is an area, a small, I think it's gas powered, and a small electric boiler we have placed here. But the distance to the consumers are quite far. Of course, we have our district heating grid placed almost everywhere, but we have no cooling pipes. So how can we develop an industrial areas like this? And there are both for and against making a central district cooling plant or heat pump central here at this place, or we could go and build decentral units at the customer side. And there will be difference in investment, of course, means of economy of scale. It'll be better at a central place, and it'll also be more feasible because of electricity fee and tariffs. At this central position, we could also easier build buffer and accumulation possibilities, which can again reduce our peak megawatt investment and avoid high electricity prices. It'll be harder at the decentral sites. Also, a very important one is the cost for connecting the customers, pipes, digging, etc. It'll be quite high, very high here to make a grid around this area with if we build it by traditional steel pipes with water, at least. And it'll be, of course, way more inexpensive to do it at the customer side. The synergy with the district heating grid is of course easy. We do it at the central placement, but it's also acceptable at the customer side. It will depend on the pipe dimensions, the district heating pipe dimensions at the actual site, because often an industry may produce more heat that they can use themselves, or need more cooling that they can use heat. So we like to distribute it through the grid to the rest of the city. And in Denmark, it's often quite quite lucky that the customers we look for cooling are also already district heating customers. So it's acceptable in Denmark, but especially this one is also why I'm actually participating in the project. I think it's very interesting to see how we could do this in a better way. And can we do some, give us more options for choosing the right production and the right distribution and heat transfer system. So that's just a short look into the machinery of Verdo. Thank you.